So the next thing that we have to start is carboxylic acid. Carboxylic acid is a dysfunctional group where there is a one carbon which has a double bond with the O and then a single bond with the O, and that single bonded oxygen further bonded with the hydrogen. Or in the simpler form, it can be written it like this. The general formula of carboxylic acid is CnH2n plus COOH, or it can be written as CnH2nO2. If we use this general formula, then we have to keep in mind that the value of the N is always one carbon less than the name, than the alk. For example, if I'm saying methanoic acid, so meth means how many carbon atoms? Yes. One. So if I'm using this formula to find the formula of the methanoic acid, so in this formula, I am going to put with the value of N 0. But if I'm using this formula, then I'm going to put the value of N1. Okay. For example, if we are talking about propanoic acid, so prop means how many carbon atoms? 3. So for this formula, the value of N would be 2, but this formula, the value of N would be 3. Is this understandable to all of you?
Yes, sir.
Okay. So the organic compounds containing a carboxyl group, this group is called carboxylic group. Ethanoic acid is commonly called a vinegar. The most common carboxylic acid that we usually use is a ethanoic acid. And ethanoic acid is also called a vinegar. Carboxylic acids are a weak acids. What does weak acid means? We have discussed it in the acid bases, that it dissociates partially in water. Okay. Now, they undergo typical reactions of acids such as with metals, bases, and metal carbonates. As they are acids. They are organic compounds, but they are acids. So that's why they undergo all the typical reactions of acid, like they react with the metal, they react with the bases, they react with the metal carbonates. If we talk about bases, so you can recall bases are metal oxides, metal hydroxide, and aqueous ammonia are the bases. Okay. Now the dissociation of carboxylic acid. So see, this is a general formula of the carboxylic acid, a general where we didn't specify which carboxylic acid is it. Instead, we write a R. So R means there can be any number of carbon atoms over here. When it dissociates to form, it produces a hydrogen ion and this ion. So this ion is called alkanoate ion. And as it's a weak acid, so we will show a partial dissociation. And for a partial dissociation, we will show this double arrow. Is this understandable?
Yes, sir.
Sir, it's a reversible reaction.
Yes.
सर मैं ये कह रहा हूँ इसे रिवर्सिबल रिएक्शन बोलेंगे ना?
Yes, for a partial dissociation, we always use a reversible arrow. And it's a reversible, the dissociation over here is a reversible, which means that these ions formed can reverse back as well. Now, for example, if I'm using ethanoic acid, see, there are 2 carbons over here, so it's ethanoic acid. So when it dissociates to form ethanoate ion and a hydrogen ion. When this hydrogen releases, the remaining part becomes a negatively charged ion, so it's called ethanoate ion. Is this understandable?
Yes, sir.
Okay. In the same way, here we have a 1 carbon, so it's a methanoic acid. So it will form, when this hydrogen is released to form a hydrogen ion, the leftover species becomes methanoate ion. See over here, there are 3 carbons, so it's a propanoic acid. So it dissociates partially to form propanoate ion and hydrogen ion. The last one. Is this clear?
Yes, sir.
Okay. Now see, these are the chemical equations of these acids with the metal. So what we know, when an acid and a metal reacts, we get a salt and hydrogen. So what we did, we made hydrogen over here. And we work out the ions and their formulas, as calcium is 2+, ion and ethanoate is -1 ion. So we move the values over here in the subscripts of each other to form the formula of the salt, and it's called calcium ethanoate because this is a ethanoic ion, right? In the same way, when ethanoic acid reacts with the zinc oxide, so here the reaction is between acid and a metal oxide. So we are going to get a salt and water. So we will make the water, we will write the ions with the formulas with the charges, and then with the help of them, we will make the formula of the salt, which is zinc ethanoate. Then we have a ethanoic acid and sodium hydroxide. So it will, again, it's a metal and it's an acid and a base, so salt and water would form. So we will write the water, we will write the ions with their formulas, and with the help of those, we will make the formula of the salt, which is sodium ethanoate. Is this understandable to you guys?
Yes, sir.
Okay. Now, last one, acid is reacting with the copper carbonate. So see, this reaction is between acid and a metal carbonate. So we know when acid and a metal carbonate reacts, we get salt, water, and carbon dioxide. So we will write first water and carbon dioxide. Then we will write the formula of the ions with their charges, and with the help of these ions and their charges, we will make the formula of the salt. So here the salt is copper 2 ethanoate. Is this clear?
Yes.
Yes, sir.
Okay, if any one of you has any confusion, please ask. Okay. Now after this, how to prepare a ethanoic acid? So ethanoic acid is basically prepared by the oxidation of alcohol. And we have discussed this reaction in the alcohols. If you recall the last class, last Thursday, see, we have discussed the oxidation of alcohol, and when we oxidizes the ethanol, we get the ethanoic acid. So in the same way, if we oxidizes any other alcohol, it will form carb, and this respective carboxylic acid, like if you oxidizes propanol, you will get propanoic acid. If you oxidizes butanol, you will get butanoic acid. Is this understandable?
Yes, sir.
Okay. Now, we have that is the last reaction over here. Then we will move towards the polymerization. Esterification. So it's a chemical reaction in which carboxylic acid reacts with alcohol in the presence of a catalyst, sulfuric acid. Okay. So sulfuric acid is used as a catalyst, and in this reaction, what we do, we warm the solution, or we heat the solution of carboxylic acid and alcohol. We mix them. We add some sulfuric acid, and then we heat it. On heating, a new organic compound is called, and that new organic compound is called ester, and that's why this reaction is called esterification. Is this clear? Okay. This reaction is also called condensation reaction. Why? Because when the ester is formed on the reaction of carboxylic acid and alcohol, a small molecule like water is released. So this is the type when these are called condensation reaction, when two molecules reacts and join together, and as a result they releases a small molecule like water, or sometimes instead of water there can be an HCl. So when these are released and a bigger molecule is formed, then it's called condensation reaction. Okay. Esters have a sweet fruity smell. So when the ester is prepared or is formed in that reaction vessel where we have performing the reaction, we are going to observe a sweet fruity smell. And all the fruits have a natural esters in them, and due to those esters, they have a very specific fruity smell in it. For example, if you cut the mango, you will feel a unique smell. In the same way, if you cut a watermelon, or if you cut any other fruit, you will going to get a specific smell. Okay, esters are used for food flavoring, perfumes. These are the two uses common use of the esters. Besides this, they can also use as a solvent as well. Is this understandable to all of you till here?
Yes, sir. Yeah.
Yes, sir.
Okay. Now, have a look at a word equation. In this word equation, a carboxylic acid is reacting with an alcohol. In the presence of sulfuric acid, and we heat it. See, carboxylic acid is a weak acid, so we will put the reversible arrow over here. Okay. So ester is formed along with the water. Till here, is this clear to all of you?
Yes.
Okay. Now have a look at these equations. If you see this, these two are the same equations. The first one, this one is with the displayed formula. So is with the structure, so you can easily understand how the ester is formed. And this one is with the structural formula only. If you see, this is a carboxylic acid, right? And this is an alcohol. So remember, when the carboxylic acid and alcohol reacts in the presence of sulfuric acid, carboxylic acid going to release the OH and alcohol is going to release the hydrogen. Is this understandable?
हेलो सर
Yes.
सर आप क्या कोई कनेक्शन प्रॉब्लम हो रहा है आवाज नहीं आ रही थी आपकी और स्लाइड भी अपीयर नहीं थी
अभी भी नहीं हो रही शो स्लाइड?
नहीं सर अब आ गई है पहले वो हैंग हो गई थी
Okay.
H2 पे
Sir, water is always formed along with acid.
Yeah, with the ester, when we use carboxylic acid and alcohol, ester, water will always form. So see, from carboxylic acid, OH is released, and from alcohol, H is released, and this O gets bond with this H to form water. Is this understandable to all of you? Yes, did you guys
Yes.
understand this?
Sir.
So see, that's what happened. OH and this H will form a water over here. Is this clear? Now, when you are writing the ester, you can write the ester in two ways. See, if I write this thing over here, if I have started with the part of the carboxylic acid, so I made the remaining part of the carboxylic acid over here. Is this clear? Yes.
Yes.
Okay. Now, from here, hydrogen is released. So if something, it means that something is going to bond with over here. So that's why we have flipped the part of the alcohol, if you see over here. That's why the alcohol part is flipped and the oxygen of the alcohol from where the hydrogen is released, it gets bonded with the carbon of the carboxylic acid from where the OH is released. Is this understandable? Is this clear?
Yes, sir.
Okay. Now,
Yes, sir.
if instead of carboxylic acid, if I start with the alcohol part, see like this. So I will write CH3O like this. Now what I'll do, I will flip the carboxylic acid part because from here the OH is released. So this carbon is flipped over here because this carbon is going to bond with this oxygen. So it can be written anyways. If you start with the carboxylic acid, you have to flip the alcohol part. If you start writing ester with the alcohol part, you will flip carboxylic acid. Is this clear?
Yes, sir.
Okay. Now, when the ester is formed, the alcohol part is named as an alkyl. So see, it's a methanol. So that's why it becomes methyl. And the carboxylic acid part becomes alkanoid. So it's a ethanoic acid. So it becomes ethanoid. So that's how we will name it. It is going to be methyl ethanoid. Is this understandable to all of you?
Sir, can you explain it?
From where?
How to name the
Yes. From where?
sir? How to name them?
How to name it? Okay.
Name them.
Yeah, sure. The part of the alcohol is called alkyl. The general name of ester is alkyl alkanoid. So this part, the alkyl actually comes from alcohol. So it's a methanol, right? So it becomes a methyl. And this alkanoid parts comes from carboxylic acid. So the name of the carboxylic acid is ethanoic acid. So that's why it becomes ethanoid. So the name will be methyl ethanoid. Is this clear?
Okay.
So see, it's only one carbon. So that's why we are calling it methyl. And see, isn't it the whole thing like alkanoid that we have seen in the previous partial dissociation equations of the acid? So that's why it's called ethanoid. Is this clear now?
Yes, sir.
Okay. Okay. Now if I go now see, this is the equation where we have written the normal structural formula of the ester. So this part is methyl and this is ethanoid, and this equation, this part is methyl and this is ethanoid. If any one of you has any confusion, please tell me. Yes, still here, is this clear to all of you?
Yes, sir.
Yes, sir.
Okay. Now, if I show you this structure, this half equation where it's C butanoic acid and it's a ethanol, and I ask you to draw the structure of ester. So how you will do it? Okay, the screen is stuck again. Let me. Yes, over here, if you see this one. So see, it's a butanoic acid and it's a ethanol. So from the names, we can easily able to, identify the name of the ester. So alcohol is ethanol, so it's ethyl, and carboxylic acid is butanoic acid. So the name of the ester is going to be ethyl butanoate. Is this understandable?
Yes, sir.
Yes, sir.
Okay. So now, how can we write the structure? The same way, how can we write the structure of the ester the same way as we have discussed earlier? That for example, if I start with the alcohol, so I will write the alcohol. From alcohol, hydrogen is removed, right? And now I'm going to flip this molecule because from this molecule, this OH is removed. From here, the hydrogen is removed. From this molecule, OH is removed, right? Now I'm going to put a C of this C over here, then double bond O, then flip the rest of the molecule. Or if I start from the carboxylic acid, so I will start like CH3, CH2, CH2, C double bond O. And then as OH is removed from here and the H is removed from here, so I start from here. I made the carbons bond with the O and flip the alcohol molecule. So if you start with the carboxylic acid, you are going to flip the alcohol. And if you start with the alcohol, you are going to flip the carboxylic acid, the part of the carboxylic acid in the ester. Is this understandable? Yes, is it clear to all of you?
Yes, sir. Clear.
Yes, sir.
Okay. To see after when you are able to write this, then from this you can easily able to write the structural formula like this.
सर
Yes.
सर ये जो लास्ट वाली इक्वेशन बनी हुई है, जो फर्स्ट वाला ईस्टर बना हुआ है, इसमें फ्लिपिंग नहीं शो हुई.
See over here, if you see this one, we have started from here. So see, initially we have a 3 carbons and 7 hydrogens, so we write them. Then we have a C double bond O and O, so we wrote them. Then we have a C2H5, so we just wrote them. If I start from here, so see, there are 2 carbons and 5 hydrogens. Then there is a O and C, this thing. And then 3 carbons and 7 hydrogens. See, the flipping is there because see that there is a C double bond O and here OOC.
Okay, sir. Clear.
So here it means that it is written like this. And here it is this, it is written like this. Okay. Now see, this is a methanoic acid and this is a ethanol, right? So from here OH is removed, from here H is removed. So see, this is over here, and from this O, we flip the molecule and see this O actually gets bonded with the over here, and this molecule, the CH2 and CH3 part is flipped. And if you see over here, we have started with this like this. And then as this group and this groups are removed, so this carbon gets bonded with the O. And as a result, this part gets flipped over here. Is this clear?
Yes, sir.
Okay. So as the alcohol is ethanol, so the alcohol, due to the alcohol, it's going to be ethyl, and the carboxylic acid is the methanoic acid, so it's methanoate. So its name would be ethyl methanoate. Yes, Mushtaba. Okay. After this, we have this one. If you see, there are 3 carbons. It's a propanoic acid, and there are 4 carbons, so it's a butanol. So the name will be butyl propanoate as the alcohol. As the alcohol part has a 4 carbons, so it becomes butyl, and the carboxylic acid part has 3 carbons, so it becomes propanoid. So same thing will happen. OH from here and H from here. If I start from here, so I'm going to bond O with this carbon, and this whole part is going to be flipped like this. And if I start the ester from here, so this would be written like as it was written on the reactant side. And as this OH is removed and this H is removed from here, this H. So this carbon going to bond with this oxygen, and as a result, this whole part is going to be flipped if you see over here.
सर अल्कोहल का सबसे पहले नाम आएगा ना, फिर
Yeah, so the
Carbon.
number of carbon atoms in the alcohol will help us to identify the first name of the first part of the ester, that is alkyl. Clear? Is this clear to all of you?
Yes, sir.
Yes.
Okay. Okay. So here we are done with the carboxylic acid. Now we are left with the polymerization, and we are going to do the polymerization on Thursday. Okay. Let me know one thing.